Small increments. Consider a rectangular prism or cuboid with a square base. It's the same one that we used in the introductory situation. Suppose that we increase x to x plus delta x and y to y plus delta y. We want to show that the change in volume is approximately dv dx times delta x and dv dy times delta y. And then we're going to consider a particular situation after we've done that. So let's start with v being equal to x squared y. That means that dv dx is 2xy, and that dv dy, remember x squared is just a constant in this regard, is just going to be x squared. So v plus delta v is going to be, so the base will become x plus delta x times x plus delta x. So that's x plus delta x squared. And the height will become y plus delta y. So that would be the new volume. So we can expand that out. And we get x squared plus 2x delta x plus delta x squared multiplied by y plus delta y. Expanding that out gives me x squared y plus 2xy delta x plus delta x squared times y plus x squared delta y plus 2x delta x delta y plus delta x squared delta y. That means that delta v, and that means subtracting v from both sides, and on this side that would be v, and on this side that's x squared y. So that's going to be 2xy delta x plus x squared delta y plus delta x squared y plus 2x delta x delta y plus delta x squared delta y. Now the idea is that delta x and delta y are small, and that means that anything that contains a delta x squared or a delta x times delta y, and here a delta x squared delta y, those are going to be so small that we ignore them as being, for all intents and purposes, 0. And that leaves us with 2xy delta x plus x squared delta y. And then if we refer back up here, that means 2xy is dv dx. So we have dv dx delta x, and x squared is dv dy. So we have dv dy delta y, which is the formula that we were trying to show. So let's look at a particular situation. Consider the situation where x increases from 5 centimeters to 5.01 centimeters, and y increases from 10 centimeters to 10.01. Well, the true volume would be 5 times 5 times 10, which is 250 cubic centimeters. And then the new V, once we've done the increase, is 5.01 squared times 10.01. And we can calculate that, and it comes to 251.252001. So that is the exact new volume when we make those increases. Now let's try that using our increments formula. So delta V would be, now in this case, remember, this comes to 2xy delta x plus x squared delta y. So that is going to be 2 times 5 times 10 times 0.01 plus 5 squared times 0.01. So if we calculate that, so we've got 100 times 0.01, add 25 times 0.01, gives us 1.25. And that means that the volume estimated using this formula would be 251.25. So you can see that this is the difference when we do it exactly. And those numbers are pretty small down there. This is in the thousandths column and so on. So we do get a fairly good estimate. And of course, if our increases are much smaller, the estimate will be better.